What's up, guys? Nate Morris, MasterLSAT.com. In this video, we are going to practice a pretty tricky inference question. This question is taken from an official LSAT. It's a question that a lot of people struggle with. However, as usual, of course, I changed the words around from the question, so it's not exactly the same as the question you'll see on the official LSAT, but it's fundamentally the same question. We just changed some stuff around. So why don't you go ahead and see if you can get this question, pause the video, see if you can work through it, and figure out what the answer is. Okay, so I'll assume that you've had a crack at this question. Let's go ahead and look through it together. So it says, which of the following logically follows from the information above? Which means we want to look for an inference. If all the above is true, which of the following is probably true as a result, right? So as always with inference questions, we want to see if we can predict where it's going. We want to read the paragraph and pretend the paragraph is followed by the words, therefore, based off all the above, therefore blank. And what would you think that inference would be? Because if you have an idea what a logical inference would be from the paragraph, if you, so to speak, put two and two together from the paragraph, it generally means it's leading you in one direction. And if you can figure out what that direction is, then that's going to be the answer pretty much all the time. So let's read this paragraph. It says, all of the students at Sunshine University live in one of two residences, either Hartman or Fisher. Although just a small fraction of the classes offered at Sunshine are science classes, 54% of Sunshine students take at least one science class. That number is lower for Sunshine students living in Fisher. Only 42% of those students take at least one science class. So what did they tell us here? They told us that 54% of Sunshine take a science class, right? They gave us that figure for the totality of Sunshine students overall, the entire college. 54% of those students take a science class. Now we know that the whole college is divided into two residences. Everyone's either Hartman or Fisher. And we know when we put those two things together, 54% of the total students take at least one science class, right? That's what they told us in this sentence. Then they gave us another number, right? They said that when we isolate just Fisher, when we just take one half, well, it's not necessarily one half, but when we take one of the two parts, one of the two residences, and we just look at the students in that one of two residences, then that number drops. It's only 42% of those students, 42% of the Fisher students who take a science class. Now, when you're looking for an inference, you want to always ask yourself, well, what's missing? If we put stuff together here, what's the missing piece of the puzzle that they didn't tell us, and can we figure that out? So in this case, they gave us the total percentage of all Sunshine students who take a science class. Then they told us the percentage of Fisher students who take a science class. So can you find the inference here? See if you can figure out what the inference is. And the hint is that the inference is going to be about the other residents. It's going to be about Hartman, right? They told us 54% of Sunshine students in total take a science class. Then they told us it's only 42% of Fisher students who take a science class. So the missing number, the one that you should be thinking about is, well, what percentage of Hartman students take a science class? Do we know anything about that number? Can you figure anything out about what that number might be? And to illustrate this, I'm going to give you another example that will often make it a little more obvious. Let's say I told you that half of Americans watch football on TV. Okay, so half of Americans watch football on TV. And let's assume for our sake that America is made up of men and women. So if I say that half of Americans watch football on TV, but then I tell you only 20% of women watch football, well, what would you know about the percentage of men that watch football? Now, you wouldn't know the exact percentage, but you would know something about it. You would know that it must be greater than 50%. Right? Because 50% was when I combined the whole country together, it was half the country watches football. But only 20% of women watch football. That must mean that more than 50%, like let's say 70 or 80%, we don't know exactly what the division of men and women is, so it's going to be a weighted average. So we're not exactly sure, but it certainly has to be more than 50%, right? Because if when we put men and women together, it ends up at 50%, and if you just isolate women, it's 20%. Well, then that would mean that if you just isolate men, it would have to be more than 50% so that they could even out in the middle, right? Because let's imagine the opposite. In case that isn't clear, let me just make that a little extra clear. Let's say 20% of women watch football and also 20% of men watch football, well, that would literally mean, if the country is just made up of men and women, that would mean that that 20% of the whole country watches football, right? Let's say 20% of women watch football and let's say 24% of men watch football. Well, then when you put them together, it would average out and be somewhere in between the 20 and the 24. Now, it wouldn't necessarily be exactly halfway in between because that would assume that there's exactly the same number of men as there are women, but it would certainly be somewhere in between, right? So therefore, if I already know the final number, if I know the total average of all Americans that watch football, the percentage of all Americans that watch football, including men and women, is 50%. But if I just extract women, I know it's only 20% of women that watch football. It must be way more men. It must be more than 50% of men that watch football, so that brings up the aggregate to 50%. So hopefully that clarified that point a little bit. We're dealing with the same thing here, right? Because we know that 54% of Sunshine students take a science class. When we isolate Fisher, it's only 42% of Fisher students that take a science class. Well, let's think about that. That means that more than 54% of Hartman students have to take a science class. That is the therefore statement that you should be imagining at the end of this paragraph. That's if you put 2 and 2 together, if you put this number together with this number, that's the thing that you should realize, right? If it's 54% of the total that take a science class, but then when we isolate Fisher, it's only 42%. Well, if we isolated Hartman, and let's say Hartman was also only 42% of Hartman students take a science class, well, that wouldn't make any sense, right? Let's say only 43 or 44 or 46% of Hartman students take a science class. That also wouldn't make any sense, because if it's 42% of one residence that take a science class and 46% of the other residents that take a science class, well, then the percentage of the total would have to be somewhere between 42 and 46, right? So therefore, since the percentage of the total is 54, we know that 54 has to be somewhere in between the two numbers, right? Which means if 42% of Fisher students take a science class, it would have to be somewhere more than 54% of Hartman students that take a science class. That's the missing number. That's sort of the missing piece of the puzzle that you should sort of, your eyes and your mind should sort of be directed to here, because they gave you two numbers and there's clearly a number missing. And that's the number of Hartman students, the percentage of Hartman students that take a science class. Again, we don't know what the percentage is. It could be only 55%, right? Because we don't know how many students there are at Hartman and Fisher, right? So let's say there's way, way, way more students at Hartman than at Fisher, then it could be that Hartman, it's only 55%. And even though Fisher is a lot less, it doesn't have as much of an impact on the average. But so anyway, that's going into a little more, maybe a little more intense math than you're interested in, being that you're, studying to become a lawyer. But that being said, it's at least true based off simple quantitative logic that the percentage of Hartman students that are taking a science class must be more than 54%. So let's see if we can find an answer that says that. Now, in fact, there is an answer that says exactly that, as there is on the equivalent of this question on the actual LSAT. But let's go ahead and look through the answers and see if we can rule them out one by one. So do we know that A is true? A says science classes at Sunshine have larger enrollments on average than non-science classes do. Now, that we certainly don't know, because we have no idea what the enrollments are like for the other classes. We are only told something about enrollment for science classes. Non-science classes could have larger enrollments, they could have equal enrollments, they could have smaller enrollments. We simply don't know, and therefore A is definitely not something we can infer from this paragraph. B, do we know that Sunshine students living in Hartman are less likely than those in Fisher to take more than one science class? We don't know anything about differentiating between people who take at least one science class versus people who take more than one science class, right? All of these statistics in the paragraph are about people who take at least one, right? At least one science class, at least one science class, and they all might be taking exactly one science class, or maybe 99% are taking one and 1% are taking 2 or 3 or 4 or 5, or maybe 99% are taking 7 and the other 1% is taking 15. We literally have no idea what at least one means, so we cannot differentiate. We don't know anything about how many of those at least one science class people are taking more than one versus how many are taking exactly one. We simply don't know, and therefore B is dealing with a variable that we have no information about, and so we can't infer that. What about C? Do we know that more students at Sunshine live in Fisher than live in Hartman? Well, we certainly don't know that, right? For one, we're not given any numbers to do with Hartman whatsoever, right? We're not given any information about Hartman, right? There's no way to know that C is true, right? We do know that 42% of Fisher take a science class. We know that 54% of the total take a science class. So therefore, we know that some greater percentage of Hartman takes a science class. But as far as how many people are actually in each residence, we simply have no idea. They could be evenly split. They could be 50-50. They could be not evenly split. We literally have no clue as to the division. So therefore, that's not the right answer. What about D? Do we know that more than half of the students who take science classes at Sunshine are from Hartman? No. The same reason we didn't know C, we don't know D either. We don't know how these students are divided. We don't know how many come from each one. It could be that 1,000 students are in Fisher, and it could be that only 50 students are in Hartman, in which case 42% of 1,000 is going to be much bigger than however many students, whatever percentage, even though it's going to be greater than 54%, right? Let's say it's 60%, 70%, 80% of that smaller number of students might not be bigger than only 42% of 1,000 students. Now, I don't know if these numbers are actually going to, make sense if you do the math. I'm giving you an example, right? I'm saying that just because, meaning we do know that more than 54% of Hartman students take a science class, right? So we know that that's a higher percentage than the ones from Fisher who take a science class, right? But that doesn't mean there's a higher number of students, right? Because there could be fewer students. It could be a higher percentage of a lesser number. There could be fewer people in Hartman by a large margin, and therefore, even though it's a higher percentage, it could be a higher percentage of a much smaller number, and therefore it might end up being less Hartman science students than Fisher science students. So that's why we don't know. Hopefully that makes sense. That's why we don't know that D is true. E is exactly what we were looking for. More than 54% of the students at Sunshine who live in Hartman must take a science class. Again, just one final time, we must know that that's true, because if it weren't, then where would this 54 come from, right? We know that 54% of the total university take a science class, right? And we know that when we isolate Fisher, it's less than 54, which must mean that in order to average out at 54, when we isolate Hartman, it must be more than 54, which is exactly what E says, as we pointed out a few times. Hopefully this makes sense. And we can see that clearly E is the right answer here. And again, we could have predicted that from reading the paragraph. It was certainly the inference that we were directed to from having read this paragraph. Thanks for watching. If you like this video, please be sure to give me a like on the way out. And if you want to see more videos like this, be sure to hit subscribe. If you want to see thousands more videos like this, be sure to head over to masterlsat.com. If you found this video useful, don't forget to hit subscribe. And for thousands more clear LSAT explanation videos, go to masterlsat.com.